So today we will talk about transactions first, and then we will go on to indexing. Right. Transaction is, what is a transaction? What would you say a transaction is?
Sending or receiving something becomes a transaction.
Okay, that is in the colloquial term, right? But when it comes to databases, right? So in terms of databases, a transaction is a set of commands that behaves like one, right? A set of commands behaving as one unit, behaving as one, what is called atomic unit. Right. And transactions are very important when it comes to especially financial transactions, financial applications, and generally in other applications also. But it's more critical when it comes to financial applications. Right. So we will take a simple example of a simple bank transaction. Right. So let's say you want to transfer some amount from one account to another account. See, although I'm using the example of a financial transaction, transactions are applicable everywhere, right? So not just giving and taking money, right? It's just that we want a set of commands to behave like a single unit. So we'll see why we want that, right? So let's say we are thinking of transferring money from one account to another account, right? So if you think of it purely from a database point of view, right? So you will have, let's say you have an account table, right? So where you have the account ID or account number, the name and all will be there, right? So name. Then let's say balance, right? So the current balance. So account one, let's say John has some 50K in his bank, in his account. Account two, let's say is Tom, who has some 20K in his account. Now what we want to do is we want to, from account one to account two, we want to transfer some 5K, right? So here we have 50K, here you have 20K. So now what we want to do is, let's say I want to transfer some 5K from here to here, right? So I'm transferring 5K from here to here. So after this transaction happens, right? So after this transfer happens, what we need is we want, we expect this to be 45K, right? We expect this to be 25K if everything goes properly. So in addition to this, usually what the banks and all will have is something like a transaction table where you keep track of everything that is happening in a day, right? So the account number, what kind of transaction, right? So what is the amount, for example. So here, if you think of it in terms of database operations, right? So what is happening in the account table? We are doing an update, right? So we are updating the balance and setting the balance. So this is what we have done is a debit operation. So this would be, we will say update accounts table, right? We are setting the balance, set the balance. Set the balance equal to the old value of balance minus 5K, right? Where account number is equal to A1. So this is the debit operation. How about the credit operation this side? This is also an update command, right? So we will update accounts, set the balance equal to balance plus 5K, right? Where account number is equal to A1, A2, right? So this is the credit operation. Then this operation will be logged in the transaction table, right? So here we will say account number 1 debited 5K, right? And here we will say account number 2 credited 5K. So these 4 operations, so this is an insert operation, right? So we need 2 insert operations. So we'll say insert into transactions. Into transactions, right? So values, this 1 debit 5K, right? And again, we have an insert command, insert into transactions to credit 5K, right? So account number 2, or this is A1, no? A1 and A2. So A1 debited so much, A2 credited so much. So all 4 operations, right? So all 4 commands should be executed for this transfer to happen successfully, right? This is what we mean by one transaction, one set of commands, okay? Only when all these commands are completed, we say that this transaction of transferring 5K from here to here is successful. What will happen if one of them fails, right? So let us say this was successful. This succeeded, this succeeded, but this failed. What will be the result now? This will become 45K, right? Because this operation was successful. This will still remain 20K only because this operation failed. But these 2 were successful, right? So there will be an entry in the transaction saying this was debited and this was credited. So now do we have inconsistent data here? There is no record of what happened to the 5K, right? It was taken out from here, but it never came here. And why did that happen? Because one of these 4 operations failed. Is that fine? Are you getting what I'm saying?
Yes, ma'am.
So this is what we mean by inconsistent data, right? Your data is inconsistent and we'll never be able to trace what happened here. So what we need to do is we have to find some way so that all 4 transactions will be successful, right? So update for the debit operation, the update command for the credit operation, the insert command for the debit, insert for the debit, and the insert corresponding to credit. These 4, we have to ensure that they will succeed all the time. Sorry, all of them will succeed. If at all anything fails, right? So we have to make sure that everything fails. So it is okay. You can try to transfer from here to here and you can say the transfer failed. But even if the transfer fails, what should happen? The resultant should be, you should have 50K here, you should have 20K here, and there should be no records inside this, right? So it should go back to the previous stage. So this is where this is what we mean by a transaction. We want a set of commands to all of them should succeed. Or if one of them fails, we should make sure that everything fails, right? All success or all failure is what we want. So we'll come back to this, right? To do this, we use the idea of commit and rollback. So commit means save. Rollback is undo, right? So let's first understand commit and rollback, and then we can see how we can use commit and rollback to implement a transaction, right? So before we do that, we have to see what happens at the back end, right? So when you say insert into something, right? Remember in the very first class, we said you can think of the database as being made up of the permanent storage, right? Or persistent storage. This is the hard disk, right? So this is persistent or permanent storage. And then we said there is something called the DBMS, or in our case, it is the RDBMS, which RDBMS, which is handling this, which puts data into this and fetches data from here, right? But actually what happens is RDBMS will not directly put data into this. Instead, the data will go first into what is called a cache, right? So a cache or a buffer memory. So this goes into a cache or a buffer, right? So this will be in the RAM. Only, so if you say insert, right? So we say insert into some table, right? So employee, employee 1, Tom, manager, right? So if this record will not directly go to the persistent storage, Tom will first go into the cache, right? And only when you say commit, right? So only when you say commit, this will be moved from the cache into persistent storage. So once it goes into persistent storage, it becomes permanent, right? You cannot undo a transaction that has been moved into persistent storage. So when you say commit, this record is removed from the cache. It goes into persistent memory only when you say commit. And once it is committed, you have saved that record. You cannot do undo of that. If you really don't want this record, you have to delete it from memory. You have to say delete from something, right? You can't say Control-Z or you can't say rollback. But as long as your record is in the cache, you can do rollback of it, right? So I can say, let's say I insert the second record into EMP. I insert Mary's record, right? So Mary is a programmer. So Mary first goes into the cache, right? And I never said commit. So Mary remains in the cache. As long as Mary is there in the cache, I can say rollback. So if I say rollback, what will happen? The record will be deleted from the cache. It will never go into persistent memory, right? You can say rollback and you will see that whatever you inserted is gone. Okay. Are you fine till here? Any questions here?
No, ma'am.
No, ma'am.
Fine. So let's try this, right? So we will first insert a record into the table and we will try to do a rollback of it. So let's look at our students table. What do we have in that? Select star from students. Okay, so let's insert somebody, right? So we will insert into students values 6 Larry and 34 and analytics, right? So if you now select star from students, Larry is there. If you try a rollback, right? So if you say rollback, we are doing an undo of the insert, which means it should go away, right? We don't want that record. We inserted it by mistake or we want to take it away, right? So now if you check the table, right, you see that Larry is still there, right? So the rollback did not work. It did not undo the change. So the reason it is not getting removed, right? So the reason you are not able to do an undo of this is because by default in your server, there is a parameter called auto commit, right? So this is by default turned on in your server, right? So auto commit is by default turned on. So if this is on, what will happen is whenever you do a DML operation, any insert, update, and delete you do, the server will automatically commit it, right? So you don't have to say commit, the server will issue a commit command. So that is why the moment you insert something, right? So from the cache, it directly goes into the persistent storage because the server itself issues a commit command. So let us turn this off, right? So we can turn it off, this auto commit. So how do we do that? We will say set auto commit equal to 0. So this will turn off auto commit, right? So now it is our responsibility to commit whatever we are doing. We have to save it, right? Otherwise, whatever you do will keep accumulating in the cache. The moment you say commit, everything in the cache will be flushed into persistent memory, right? So I have turned off auto commit. So now let's try to insert somebody. Let's insert 7. Harry. Let's say 19. And let's say Harry is learning magic. Okay, so now I have inserted a record. So if I select, I see Harry here. Now let's try to do a rollback, right? So if you do rollback, you can see Harry is gone. Whatever we inserted, we are able to undo that operation. Okay, for insert, undo means it will get deleted. It will get removed from the table. If you roll back insert, the inserted record will be deleted, or undo means basically it will be taken out. If you delete something by mistake, and if you say rollback, it will be inserted back into the table, right? If you update a record and then you want to undo it, again an update will be done to take it back to the previous stage. So this is what we mean by undo or rollback, right? Was that a question? No. Okay, are we fine with this idea of auto commit? Right? What is auto commit? This is a parameter that we can set in the server, right? If it is turned on, automatically whatever you do will get committed then and there. The server will issue a commit. If you turn auto commit off, then the server will not commit it, right? So server will not issue the commit command. We have to say commit. Only then it will get saved. Fine.
Ma'am, we have to do this again and again, or it's done for now?
Which one?
Auto commit is off, right? No.
If it is off, then we have to commit it at regular intervals. If you have turned it off, then until you say commit, everything will be in the cache only. It will not go into persistent storage. If you close your session, whatever you have done will not be there in the server, right? But by default, the server will have auto commit on, so that you don't have to keep committing it. But if it is,
again, to turn on the auto commit, what will be the command, ma'am?
set it to 1.
Okay.
We will do that. Let's do that now. It's not a good idea to turn it off. Right. So what we will do, we will turn it back on. Set auto commit equal to 1. Can you turn off the echo effect? Yeah. So now auto commit is back on, right? So now if I insert Harry, right, I cannot roll back, right? So if I say roll back, it will not work because auto commit is on. The moment you did an insert, the server said commit. So Harry is taken from the cache and he is put into persistent memory, right? Fine till here?
Yes.
Okay. So keep this in mind, what is happening at the back end, right? So imagine whatever you are doing keeps accumulating in the buffer. Whenever you say commit, then everything will go into the persistent storage. No, it's not for the last one. It is applicable for whatever you did since the last commit. Right? So if assuming your auto commit is off, right? Whatever you do keeps accumulating in the cache until you say commit. So if you say commit, everything gets flushed. If you say rollback, everything from the cache will go away. Right? Or everything gets deleted from the cache. Okay, I hope that answers your question, Tushar. Yeah. Right. So now coming to transactions, right? So how will commit and rollback help us with what we want to achieve? What do we want to achieve? We want to make sure that these four transactions are, four operations happen together, right? So update for the debit, update corresponding to the credit, insert into transaction corresponding to the debit operation, and insert into transaction corresponding to the credit operation. These four we want to make sure are successful. All of them are successful. So what we can do is we will turn auto commit off here, right? At this point, we will turn auto commit off. Then we do this operation, do this, do this, do this. If all of them are successful, say commit. Now, four of them will simultaneously get updated to persistent memory. If otherwise, let's say you start here, right? So you did this, this failed. If this fails, what we will do at this point, we will immediately say rollback. So now what will happen? The updates also will get rolled back so that you go back to the previous state of, what was that? 50K and 20K, right? We did an update. This update was also successful, but this failed. So we will undo everything, right? So, and we will go back to 50K here. We will go back to 20K here. Nothing got inserted into the transaction table. We will say that the transfer failed, right? But we have ensured that the data is consistent. We didn't end up in a state where we are not able to track an operation, right? We didn't end up like 45K here, 20K here, and the transaction says everything was successful. Does this make sense? Right?
Yes,
we are ensuring that all four are successful, or we make sure that all four are failing. We don't have anything called partial success. Partial success will result in inconsistent data, right? So no partial success. So this is what we mean by multiple commands behaving as one atomic unit. This whole unit was successful or the whole unit was a failure. This is what we call a transaction. A set of commands behaving like a single unit. And why do we need it? There will be many, many places where we want to ensure data consistency. We don't want something half done, right? Only if all of these are done, then one transaction is completed. So ideally, mostly in financial transactions, this is very critical, right? If you end up losing money or if you're not able to account for some amount of money at the end of the day, then it will be a big deal, right? But not just in financial transactions, there will be other applications also where we want to make sure that multiple things have happened, right? So here, it's not a good idea to do auto commit on and off by ourselves, because it could, sometimes we might forget, or we might end up, when you're writing code, there will be many statements, when statements and all. So it is possible that you turned it off and then your code never turned it back on. Then it will be a big issue, right? So you will end up losing data. So instead, what we will do is we will use something called a start transaction command. Right. So at this point, you would say start transaction. So whenever you say start transaction, internally auto commit will be turned off. Right. So we don't have to say set auto commit off. We will say start a transaction. Immediately at the back end, the auto commit gets turned off. Then all this commands you are executing, they will remain in the cache. The moment you say commit, right, everything will go into persistent memory, and also internally this will turn auto commit on. We don't have to do, right? The moment you say commit, see, this part is where you are within the transaction. Here you are within the transaction. The moment you say commit, you are out. This gets moved to persistent, but you are also taken out of the transaction. So that means auto commit will be turned back on automatically. Similarly, whenever you say rollback, right? So you are within the transaction for this period. At this point, you are taken out of the transaction. So that means the moment you say rollback also, everything will be removed from the cache and auto commit gets turned on once again. So whenever you say commit or rollback, you are taken out of the transaction, which means auto commit gets turned on. Right? Are we fine with this? So what we need to say is, don't use this command to set it on and off. If you set it off, then it is your responsibility to set it back on after your commands are executed successfully. But you can't count on this, right? So when you're writing a program, you might forget to turn it back off, or you have written many if branches. Sorry? Maybe it never came back on, right? So instead of doing this, you will be using set or start transaction, right? And once you are done with all the commands, you will commit it, in which case your transaction is over, right? Or if something goes wrong at some point, you will say rollback. Whenever you say rollback, again, you will be taken out of the transaction, right? So what I will do is, let's create a very small table, right? So a tiny table. So you can also do this, right? So create table, TT, tiny table. I will have only one column, which can take a single character, right? So this is the tiniest table possible. So I can insert only single characters into it, right? So I can put A of values. I can put B into it, right? So now if I select star from TP, I have A and B inside it, right? Can you create this table and put A and B into it? Then we will do the rest of it. Okay, Vishali says done. Okay, fine. Ani also says done. All right. So now let me delete everything from TT. Delete from TT, right? So my table is now empty. So now let us say start transaction. Now what has happened? Auto commit is gone, right? So whatever we insert, we can still roll it back. So we will insert A, we will insert B, and let's insert C also. Right? So now if I select star from PP, I have ABC, right? But remember, auto commit is off. So that means if I say roll back, whatever I inserted from the beginning of the transaction, will everything get rolled back, right? So now if I say select star from TT, there are no records inside it. Fine. Is this what we expected? Right?
Yes, ma'am.
We did start transaction. So that means auto commit off, AC off. Then we inserted A, B, and C. So now when I say roll back, everything goes off because everything is lying around in the cache, right? And at this point, AC comes back on. Now, if I insert A, I will not be able to roll it back, right? So let's insert A or some record into this. So I'm putting C into TT. Now, if I try to roll this back, this won't get rolled back. Why? Because here the transaction ended whenever we set the first rollback. Auto commit is back on. Anything that you do beyond this will get committed automatically. Fine.
Yes.
So let me again delete from TP. Let's try committing it, right? So I will again say start transaction. Then we will insert ABC. A, B, and C. So select star from TT. So now if I say commit, then also my auto commit has gone turned on, right? So now whatever I do will get committed automatically, right? I cannot roll back anything, right? So rollback will not affect anything. I will have all 4 records in the table. Okay. So this is how your transactions work. So one thing here is what we noticed is everything that happens from the beginning of the transaction, right, gets rolled back whenever you say rollback. So this could be a little problematic, right? So maybe we need more control over this. Let's say based on some condition, I only want to roll back C, or I want to roll back B up to B, right? B and these 2 I want to roll back. That is, I want more control over what I'm rolling back. And to do that, you can use what are called save points. So save points are like some markers that you place here, right? So what we will do is we will start a transaction. Start transaction. And then we will insert A and B. And then we will create a save point at this point, right? So we will say save point, and save points need to be given some name, right? So I will call it SB. After inserting B, I'm creating the save point. So I'm calling it SB, right? Then I will insert C and D, and then we can create one more save point and call it SD. And E and F we can insert. So at this point, I can say rollback. What will say if I say rollback? Sorry, what will happen if I say rollback? What will happen?
auto commit turned on.
Auto commit is turned on, but what happens to A, B, C, D, E, F?
Recent save point is rolled back.
No, when you say rollback,
Whole of it.
everything gets rolled back.
All the save points.
Everything gets rolled back, right? Save point is just a marker. Don't think of it as part of this. So when you say rollback, everything will get rolled back. But we have an option to say rollback to SD. Instead of saying rollback, if you say rollback to SD, what will happen? Only E and F will get rolled back. Okay. And one more thing, you will still be within transaction. If you say purely rollback, just rollback, your auto commit will come back on. But if you say rollback to a save point, you are still within the transaction, right? So auto commit is still on. Sorry, still off. So at this point, if you say rollback to SD, you will come, only E and F will get rolled back. What if you say rollback to SB? From here,
CD, EF are rolled back.
all four will get rolled back, right? So you can say rollback to SD. At this point, you can, if you want, you can again say rollback to SB, right? So from here, again, these two will get rolled back. So you have more control over what it is that you're rolling back. You can either roll back these two or you can roll back these four, right? One thing to remember is there is no rolling forward. You can't say roll back to SB and then again say roll back to SD, right? So this is not possible. You cannot see if you say roll back to SB and then again roll back to here, you are trying to undo an undo operation, right? So you have done an undo up to here and then you are trying to undo that undo. That is not allowed. Once you go past a save point, all those save points are removed. You can't come back. Okay. Remember, you are removing it from the cache. Once it is gone from the cache, you don't have anything. You don't have a record of that. Okay. So at this point, you can either roll back to SD, you can roll back to SB, you can say simply roll back, right? Or you can roll back to SD and then at this point, you can say commit. So in which case, these four will get committed, right? So it gives you more flexibility here. But remember, as long as you're rolling back to a save point, you are still within the transaction. You have to say commit, right? So to make the changes permanent. Okay. So let's try this. We will do the steps exactly like what we have written, right? So let me delete everything from PT. Now we will say start. You watch, I will give you time to repeat this, right? So then you can try it yourself. So start transaction. Now let us insert A and B. And at this point, let us say save point SB. Then we will insert C. And we will insert D. And at this point, we will say save point SD. Then let's insert E and F. Right. And now if you say select star from TT, we have 6 records, right? So let's try rolling back to SD. So we'll say roll back to SD. And if you check your table, you will see only E and F are gone, right? So you have rolled back up to the save point marked as SD. So at this point, you have you can either roll back to SB, you can roll back everything, you can commit, right? So let's try rolling back to SB. So let's roll back to SB. So now what should happen? C and D should get rolled back, right? A and B will be there. So at this point, maybe we can say commit, right? Or you can say rollback, it's up to you. So hereafter, whatever you do will get committed automatically, right? So if you insert F, this cannot be rolled back because once you commit, your auto commit is back on, right? So F is not rolled back, right? Are you clear with this process?
Yes, ma'am.
Yes, ma'am.
Do you want to try it yourself?
Yes, ma'am.
Yeah. Delete everything from the table and do these steps exactly so that you can see what is happening. If you face any issues, let me know. Let me know when you're done.
Done from my side, ma'am.
Okay. I think maybe, yeah, mostly people have done. So I hope we are fine with the transaction, right? So what is a transaction? It's a set of commands that should behave like a single unit, right? So that is the definition of a transaction. And to implement a transaction, we take the help of commit and rollback, right? Commit is to make a change permanent. Rollback will undo that operation. So to understand that, you should understand the idea of cache, right? Everything goes into the cache, and from here, you have to commit it to persistent memory. Then we know about auto commit, right? So, and then how to start a transaction, when a transaction ends, how to roll back to a certain point, right? Instead of undoing everything, it gives you more flexibility, right? So you can undo to a certain point. Look at the next topic, right? Which is that of indexing. So indexing is used to improve performance of queries, right? So performance in the sense, it will improve, it will make data retrieval faster, right? It will make the process of retrieving data very fast. So index is very similar to the index that you have at the back of the book, right? So why do we need an index? If you have a book which has some 750 pages, for example, right? And you want to find a particular topic inside it. Let's say you want to look up primary keys, right? In a book which is to deal with databases. So in this case, what will happen is, if you don't have an index, you have to start reading the book from the beginning, right? So you have to browse through, start from page 1, go through each and every page until you find the topic page where you have the topic that you're looking for. But if you have an index in the book, right? So what you will do, you will not go to the book, you will not go to the beginning of the book. Instead, you will go to the index, and there you will see that primary key is in page number 437 and 552, for example. So you come here, find the page number and directly go to 437, right? So this is much faster than going through the pages one by one from the beginning, right? So this is exactly what happens when you have a table also. So if you have a table called EMP, right? You have the employee ID, right? You have some records inside it. Employee name, job, and all that, right? So let's say you have some 10 lakh employees in the table, right? So 10, 100, 1000. And if you're asked to find an employee, right? So whose employee ID is 9,64,538. So if you're asked to find this employee, right, what will you do? You have to, let's say instead of a table, let's say this is an Excel sheet, right? Imagine that this is an Excel sheet, which somebody has taken a printout of this Excel sheet and they have given it to you. And from this Excel sheet, they are asking you to find the details of the employee whose employee ID is 96532. How will you go about doing it? You will start scanning from the beginning, right? So you will go through all the employees one by one until you find the record whose employee ID is 964,538, right? That's what you will do.
Yes.
Yes.
So when you say you are going through these, what you are doing is you are doing so many comparisons. Basically, you are checking is 1 equal to this, is 2 equal to this, is 3 equal to this, right? So how many checks do you have to do until you find this one? Probably you have to make 9,64,538 comparisons before you find the record that you want to find. So this is exactly what happens in a table also. Whenever you say select star from EMP, where employee ID is 964,538, your MySQL will go to the employee table and it will start checking from the first record onwards. It will go through all the records until it finds the record that it is looking for, right? So this process is what you call a full table scan. Starting from the beginning, right? So you go through everything and this is what you call a full table scan. And this is kind of very fast, very slow. If you have to look at every record one by one, right? So this is where indexing can help you. So indexing will help you to find the records much faster. And the way they will do that is, so when you think of data in memory, right? So you can think of memory as a series of shelves or slots or something, right? So let's say this is your memory. And this is divided into different cells, right? Or slots or shelf or whatever you want to think. And each of this is given a number, right? Each shelf is given a number. So whenever you say insert into, right? So when you say insert into EMP, the first record, let's say 1, Tom and manager. So this will be written into whichever slot is free, right? So this might be full, this might be full. So this is free. So here MySQL will write the record 1, Tom, manager, right? So if you know where the record for Tom is, let's say instead of 1, let's say this is 198, right? So this is 198, Tom, manager. So if you know that the record corresponding to employee ID 198 is stored in this shelf, if you know this number, you can directly go and fetch it, right? So though there is no need to start from 1 onwards and look at every record until you find this one. So this is called the memory address, right? So this is called the memory address of this record, right? So if you know the memory address of a record, you can directly go there, fetch the record and come back. No need to start searching. It doesn't matter if it is 9 lakh or 90 lakh. If I know that the record corresponding to 964,538 is stored in memory location 5020, I don't have to start searching from here, right? So I will go directly to this shelf called 5020 and I will fetch the record from there, right? So this is where your indexing helps you. indexing helps you to find the address of the record. See here, you can think of the page number as the address of the topic called primary key. Right, so you can think of it like the topic called primary key is stored in this particular location. You go there and get details about it. Right, so that is what index does. It allows us to finds the memory address of the records. Okay. So how does it go about finding the memory address? So again, it depends on what type of index you are using, right? So indexes can be classified into two categories. One based on the structure. The second based on the data type. What type of data on which are you creating the index? So based on the structure, you have something called the B-tree index, and you have something called the hash index. Right? And based on data type, you have unique index, you have spatial index, and you have full text index. Right? So today, let us try to understand what is B-tree index. So B-tree stands for balanced tree, right? And it uses the concept of binary search. Are you familiar with the binary search process? Have you come across that anywhere?
No.
Okay. So what happens in binary searches? Let's say you have this set of employee records, right? So what it will do first is it will arrange the records in ascending order. So here I have taken an example, right? So where we have this table called employee and we have 8 employees in the table, right? So here we have arranged the employee IDs. By the way, before we move on, right? So here I took the example of having an Excel sheet, right? So a printed sheet. So if you have a printed sheet and I'm asking you to find the employee whose employee ID is this much, right? Where will you search? On which column will you search? Will you search the entire record or will you search only one column?
Oh. One column.
One column. You will only search in the employee ID column. Once you find this, then you will get the entire record, right? So if you want to make this search faster, it will be really good if you can have a Control F option on this column, right? Similarly, if you are asked to find a record whose employee name is Tom, so in that case, you will be searching in the employee name column only. So if you want this particular search to be fast, you have to create an index on the employee name column. If you want this search to be fast, you have to create an index on the employee ID column, right? So let's say I have 2 commands. The first one is select star from EMP, where employee ID is equal to that big number, right? So EID is equal to that 964538. This is the first query. The second query is select star from EMP, where ename, right? So ename is equal to Tom. Let us say I have created an index on the employee ID column, right? So to make the retrieval faster. Which will both queries be fast or only one query will be fast? I have created an index on the employee ID column. What do you think?
First, we'll retrieve data fast.
Yes, first.
This one will be faster, but this will work as usual, right? If you have created an index on employee name also, then this will also be fast. So the main idea here is indexes are created on columns right? So indexes should be created on specific columns. It is possible to have multiple indexes, right? So you can create multiple indexes on a table. Ideally, I mean, technically speaking, you can have an index on every column if you want, right? So on a table is possible, right? So there can be multiple indexes on a table. But the idea is an index, whenever you say an index, you can think of it like it's created on a table, on a particular column on a table, right? So in this example, let us say I have created an index on the employee ID column, right? So let's say I have given it the name EIDX or something. So I have created an index on this particular column. So if I have created a B tree index, right? So what it will do is, it will first arrange the records in ascending order, like you have done here. Now let us say our task is to find the employee ID equal to 59, for example, right? So if you don't have an index, what will happen? It will start searching from the first record, right? Until this record. So how many comparisons should it make to find 59?
7.
7, right? So it has to make 7 comparisons, only then it will find 59. But instead, let us say we have created an index on it. If you have created an index and you're searching for record 59, first what it will do is, it will arrange it in ascending order, then it will find the midpoint, right? So the midpoint of these 8 records is 46. So first it will check, is the employee ID greater than 46 or less than 46, right? In our case, it is greater than 46. 59 is greater than 46. So if it is greater than 46, it will ignore these 4 records, because we know that what we are searching for is on this side, and this we don't have to search, right? So now I don't have to search in 8 records. I just need to search within 4 records. Okay. Now what it will do, on this side, it will divide the data in the exact middle. So the midpoint for these 4 records is 56, right? So the next check it will do is the employee ID greater than 56 or not? So in our case, it is greater than 56, right? It is yes, because we are looking for 59. So that means I have to search in these 2 records. I don't have to worry about these 2 records. So for these 2 records, the center point is 61, right? So I will say employee ID greater than 61. If it is yes, right? It could be no. If it is yes, then what the record you are searching for is 63. If it is no, the record you are searching for is 59, right? So in this case, we are searching for 59. How many comparisons did it make? How many comparisons did we do to find 59?
3.
3 comparisons, right? So we have done 1 comparison here, 2 here, and 3 here. So instead of doing 7 comparisons, we are able to find the record in 3 comparisons. So any one of these records, right? For these 8 records, whichever record you want to find, you will be able to find it in exactly 3 steps or 3 comparisons, right? So this is much faster than doing 7 comparisons. Here, it may not make much of a difference, right? So you may not be able to appreciate it. So the reason that we are able to find it in 3 steps is because you can write 8 as 2 power 3. Right? So that is why any one of these 8 records you can always find in 3 steps. Let's say your table has 1000 records, right? And you're looking for record number 995. So in this case, what you have to do, if you don't have an index, you have to make 995 comparisons. But if you create a binary tree, right? So if you create a B tree index, this 1024 can be written as 2 power 10, right? So that means any of the 1000 records, you can always find in exactly 10 steps. Can you see how much reduction there is? Right? Instead of doing 995 comparisons, you will be able to find any record within this 1000 records in exactly 10 steps, which is a big improvement, right?
Yes.
So the more records you have, right? So if you have 10 lakh records, 1 million records. So 1 million, you don't have to do 1 million comparisons. Instead, probably around 1000 comparisons you can do, and you can find any of those 1 million records, right? So let's complete this tree. What will happen? So this is EID greater than 56. What if EID is not greater than 56? Then which set of records are we talking about? If it is less than 56, then we are looking at these two records, right? So now we have to find the midpoint of these two, and I will check, is EID greater than 51 or not, right? It could be greater than 51, or it could be less than 51. If it is greater than 51, we are searching for 53. If it is less than 51, we are searching for 49. Right? If you come to this side of the tree, right here, if it is no, then we are looking at these 4 records. What is the midpoint of these 4 records? It is 33, right? So we will say EID greater than 33 or not. If it is yes, then we are looking at these 2 records, right? So the midpoint of that is 39. So we will say EID greater than 39. Then this could be yes. This could be no. If it is yes, which record are we talking about? EID greater than 39.
43.
43.
43.
If it is less, then we
35.
35, right? This side, greater than 33 is no. Then we are looking at these 2 records. Midpoint is 29, right? So EID greater than 29. This can be yes. This can be no. If it is no, we are searching for 27. If it is yes, we are searching for 31, right? So this is the B tree index structure. This is the index that is created, right? So this is the B tree index. So you can try for any record. Let's say you are searching for 43, for example, right? The first check is the number 43 greater than 46 or less than 46? It's less than 46. You come here. Is it greater than 33 or less than 33? It is greater than 33. Come here. Is it greater than 39? Yes. You come here. You find your number. So you came here and then you came here. Here also we made exactly 3 checks. So any of these 8 records can be found in 3 steps exactly. If you have 1000 records, any record can be found in exactly 10 steps. Right? So this process is called a binary search. This structure is called a binary tree or a balanced tree. And this is the index structure that is created when you create a B tree index. Okay. So, yeah. So now, along with this numbers, right? So we will also store in the index, where is this stored? 63 might be stored in the shelf 2020. 59 might be stored in the shelf 1011. This might be in 252, right? So this could be in 6038. This could be stored in 4092, right? So this could be anywhere in memory. So this could be at 1245. This could be stored in 25 and this could be 3422, right? The moment you find the record you want to find, you, along with that, wherever it is stored is also stored in the index. So this information you collect and you go directly to that location and get the record, right? So this is what happens when you have a B-tree index. So what are the steps that are followed? So the moment you say select star from EMP, right? So whenever you say select star from EMP, where employee ID is equal to 59. So now the first thing MySQL will check is there an index on the employee ID column, right? If there is an index, it will not go to the table. It will directly come to the index. It will come down the index and it will find the record. So it knows that it is stored in 1011. It will go there and get the record. If there is no index on the EID column, then it will go to the table, do a full table scan, and then it will find the record it is looking for. Okay, so this is the step that happens internally. So this is what you call a B-tree index, right? There are a lot of other things that we need to consider, but this is the general idea, right? So there are a lot of special cases here, which we have to consider, but you can, this is mainly the idea behind your B-tree, right? So basically it does a binary search. Is that fine? Right, so
Yes,
hope you get an idea of why creating an index is making this faster. Now coming to hash index uses something called a hash function. So a hash function, actually hashing is a very, there are many algorithms which are used to do hashing. So hash function basically takes a number, right? So let us say, this is a function which takes some number, right? It will take a number like this. It will perform some operations on it. Some hashing operation will be done depending upon what algorithm you are using, right? And it will come up with a different number, right? But every time you give 39, it will always give the same number because the same process is carried out on the number. If you give a number like 23, for example, it will perform some hashing operation on it and come up with a number like this, right? So hashing there are many algorithms that do the hashing. Depending upon that, it will take some input and come up with a different output. But every time you give the same input, you will get the same output only, right? It's not like once you give 39, you get this. Next time you give 39, it will give a different number. It's not like that. Always, if you give one number, the hashing algorithm will come up with the same number, a different number. So let us assume that our hash function is a very simple hashing algorithm. It only adds 1000 to whatever you are giving, right? If you give 39, it will tell you 1039. If you give 43, it will say 1043, right? So let's say our hash function is a very simple function. So now, what happens when you create a hash index is whenever you are, okay, let us draw the memory. This is memory. So whenever you say insert into EMP, let us say employee ID 27, George and a programmer, right? And let's say we have created a hash index on the employee ID column. So if you have created a hash index on the employee ID column, before saving this record into memory, MySQL will take this 27 and give it to the hash function. Our hash function will say 1027, right? So now this record will be stored in the location 1027. 27, George, manager or programmer, will be stored in memory address 1027, right? Next, you insert a record like 34, Mary, right? So manager. Again, because you have created a hash index on the employee ID, this will be passed to the hash function. Our hash function will say 1034. So we will take Mary's record and put it in. Actually, we don't have to do, MySQL will do all that. So this will be stored in the location 1034, right? So Mary and manager. So this is what happens when you insert the records. When you want to select it, right? So if you have a query saying select from employee, right? So where employee ID is equal to 27, right? So now again, because there is a hash index on the employee ID, this 27 will again be passed to the hash function. The hash function will say 1027. So you go to 1027 and get the record. If you want to fetch 34, 34 will be passed to the hash function. Hash function will say 1034. Go to 1034 and get the record. Fine. Now, can you tell me which one is faster? B tree or hash index?
Hash.
Hash index.
Hash index is extremely fast, right? Because we are not doing any type of comparisons. It's very, very fast, right? It's like a parking attendant here. While parking, it will tell you where to park. When you want to get your vehicle, this person will tell you this is where you put it. You go there and get it. So this is extremely fast. Only thing is, it's not always applicable, right? So inside our server, right? So our database server, there are many database engines inside it. So the DBA, when he is installing the system, he will go for a specific engine, right? So depending upon the requirement. So this hash index works only with what is called the memory DB, right? So this is an internal engine. This is a local, it stores most of the data locally in the cache. So this is very fast, right? So the memory DB, whenever your requirement is to have very fast transactions, but it's a limited storage, right? So you can't have very large amount of storage here. So there are different engines inside it. So by default, the engine that is used is the InnoDB, right? This is not as fast as MemoryDB, but this is what is by default used. Only for specific applications, you will go for this. So there are other engines, and it is up to the DBA to configure that server based on the application for which you're going to use it, right? So if you remember, when we executed a function called show create. Do you remember what that does? If you say show create books, yesterday we did this. What does it tell us?
Syntax is a syntax.
Command that we use to create.
We create the
Commands
table
and syntax.
using what
Yeah.
objects.
Show create table. So here, can you see, it says that the engine that is used is InnoDB, right? So this is the default engine that is configured. So on our system, if you try to create a hash index, it will not work, right? But if it can be changed, the engine can be changed, but we don't want to mess with this. But if you have MemoryDB, then obviously you can use your hash index, okay? So hash index is extremely fast, but it is not supported by all the engines. Only MemoryDB supports it, right? B-tree index is the default index that is created. This works under all circumstances. So if you don't specify what type of index you want, by default, it will create the B-tree index. Okay. So these are the two types of indexes based on the structure. Now, based on the data type, you see you have unique index, you have spatial index and full text index. So unique index can be created on all the common data types like numeric data types, date type of data, care, where, right? So on these data types, you can create a unique index. Spatial index is created on spatial data types. Remember when we talked about data types, we talked about spatial data types. It will store geometric shapes, right? So we will not look at this one. This is a very specialized data type. So we won't look at this one. And again, there is something called full text index. Full text index is created on text type of data. When do we need text type of data? Do you remember this? We had care, where, then text, tiny text, medium text, long text and all. Do you remember these data types?
Yeah.
Yes.
Resume, I think.
And we said if you have long text, you can store up to 4 GB of data in each cell. So let's say you have a table called books, right? So you have book ID, title, and the content of the book. This I have created as a long text. Title is somewhere care of 255 and book ID is integer, right? So when I am doing a search, why do we need indexes? We want the search to be fast. So when I'm doing a search on this book, right? So I can say, I can select records based on book ID. Book ID is equal to 20, for example. I can select based on title, right? So where title is equal to Harry Potter and something, right? Here, what do I have? I have the contents of the entire book. So book ID 20 is Harry Potter. Book ID 21 is some data science book, right? So book ID 30 will be some book on some other topic. So if I want to search within this column, can I say where content is equal to and sit and type the entire content? Right? So this is not possible. I can search based on book ID. I can search based on title, but I cannot search based on a large chunk of data. So what we need here is a Google search kind of option. So I should be able to say, find all records where content has Harry and Potter together, right? Or I can say, find everything where you have Harry but not Potter. Or find all books which has data and science together inside it, right? So these kind of search is what we are expecting. We can't directly say content is equal to and type everything, right? So if you want this Google search kind of functionality, you can create a full text index on this. You can create a full text index on this column. Once you create this index, you can use, there is a function called match that is used, which is kind of similar to pattern matching, but it will give you more flexibility, right? So this also we don't, we need not go into this, right? Because remember, we are expected to do data analysis. We are not going to work with the text processing, right? So we will not focus on spatial index or full text index. What we need is the unique index, right? So when you create a unique index on a particular column, the difference between a general index and a unique index is the moment you create a unique index on a specific column, you cannot have duplicates in that column, right? Duplicates are not possible. Where else did we see that duplicates are not possible? Did
In
we?
the unique constraints.
Yeah, when we talked about constraints, we said if you have a unique constraint, no duplicates are possible. Or if your column is a primary key, right, automatically it is unique and not null. So although we are creating a constraint, right, at the back end, what happens is an index is actually created. Right. So whenever you say unique constraint, actually an index only is getting created. Right. So remember, till now we have not created any index. We haven't seen create index command at all. Right. But if you see, I think it was in the students table. No, if you describe students. Yeah, we created a unique constraint on the student ID, right? A not null constraint on student name. So if you check for indexes on this table, how will you see if there are indexes? You will say show indexes from students. Can you see a B-tree index has been created? We didn't create it, right? So we only gave a unique constraint on this column. So you can see on this constraint, sorry, on this column, a B-tree index has been created, right? And here this column, it says non-unique is 0. So non-unique, 0 means false. So what does it mean non-unique is false? It means it's a unique index, right? So unique is true. So it's a roundabout way of saying it. Non-unique is 0 means it's a unique index. Unique is true. So a unique B-tree index has been created on the student ID column. Why? Because we just created a unique constraint. Then our authors table, we have a primary key, right? So if you say show indexes from authors, here also you see a unique index has been created, right? A unique B-tree index has been created on the author ID column because it's a primary key, right? So when it comes to creating unique index, there are two ways to create it, right? So one is it gets implicitly created. Implicitly in the sense we don't say create index, right? So we said something else and automatically it got created. Implicit, right? So if you create a unique constraint on a column, at the back end, actually a unique index is getting created, right? If you create a primary key on a column, it automatically creates a unique index. So if you have a primary key, no need to go and create an index on your own. Otherwise, you can explicitly create an index by using the create index command. Okay. So how do we use the create index? You will say create, right? And then you can say unique, spatial, or full text, right? Index, name of the index, some index name. Then again, using hash or B-tree, then you have to say on what, right? So on table name, column name, right? So if I want to create a unique index on the employee ID column in the EMP table, I have to say create unique index give it a name, right? So UIDX on EMP table EID column. This will create a unique B tree index. If I don't want a unique index, I just want the index on this column. What should I say? I don't want unique index. I just want a regular B tree index. What is the command? What is this bracket telling us? It says this is optional, right? This is also optional. So if I want a unique index, then I will say create unique index. If I want just any index, right? So I don't want it to be unique. I can just say create index, name of the index. Let me call it EIDX on employee table EID column. What if I want to create a hash index? Can you tell me the syntax?
We have to mention hash.
Create hash index.
No, you
On
can
employee
look at this and tell me.
Yes.
This is the syntax.
Create in a bracket.
Create index
Bracket.
using
Hash.
Yeah,
using hash.
remember the bracket should not be mentioned. Bracket is only to say it is optional. Okay. So if you want to use unique, you directly say unique, don't give any brackets. Yeah. So now tell me, create
Index
Index using hash.
Using
name of the index using hash. Then on employee table EID column. Right? For a B tree index, you can say using B tree, but that is not needed. If you don't mention also, by default, it will create a, what do you say? It will create a B tree index only, right? So let's try creating an index. So, by the way, if you create an index, it will make a difference only if your table is very big. Right, so I have a table in a different database. So I have a table called employees, select count of star from employees. Right, so there are around 3 lakh records inside this, right? I think I have already created an index on it. Show indexes from employees. Yeah, I have already created one. Let me drop it. Drop index HIDX on employees. This is how you can drop an index, right? So, so there is a table called employees. Let us see what is there. Select star from employees. Limit to 10 records. Right, so this is what we have in the table. So now let us say I want to find everybody who joined after the year 2000, right, in 2000 or more. So what I will do, I will say select star from employees where hire date greater than or equal to, or I could have given year of, but anyway, let us say 2000 0101, right? So if you see, it has taken 0.10 seconds. 0.10 is 1/10 of a second it has taken, right? So now if I want to make this query fast, on which column should I create the index?
higher
date.
date.
Higher date.
Higher date, right? So we will create an index. So I'll say create index. I'll call it HIDX on employees table higher date column. Right? So an index has now been created. Let's execute the same query. So if you look at the time, right? So it is not even showing anything. It is showing as 0, 0. Right? So let us assume that it is 0, 0, 1 second. So it is probably lesser than that because there is no number here. Let's say it's 0, 0, 1, right? How much improvement is there? Earlier, it was 1/10 of a second. What is 0, 0, 1? 1 by 1000 will be 0.001. Yeah.
Yes, yes.
So how many times it has become faster?
100.
It has become faster by 100 times, right? Actually, it will be much faster. It will become faster by 200, 300 times. Here we are assuming it is 0.001, right? So by creating an index, you have made the query 100 times faster, at least 100 times faster. Okay. So this is how you can create an index. You know on which column you need to create an index, right? So I think let's stop here because today we have looked at a lot of theory. Tomorrow we will just do a quick recap and we will also talk about when to create an index, right? So or when you should not create an index. Right? It's not always helpful to create an index. So we'll talk about that tomorrow.